Okay, class, picking up where we left off at, we're on problem 28. We had a parenthesis 9x minus 5 plus the parenthesis 3x squared minus 8x plus 4. So this is what we need to do. We notice here there's no exponents on the outside of the parenthesis or nothing multiplying on the outside of the parenthesis either. So with addition of parentheses, all we have to do is drop the parentheses and also keep the signs the same. So we would have here, for 28, we would have 9x minus 5 plus 3x squared minus 8x plus 4. Now, we will combine our like terms and we will write this in the proper order. So the first thing would be 3x squared. 9x minus 8x will give us x. And then negative 5 plus 4 will give us a minus 1. So this is the answer for problem 28. 3x squared plus x minus 1. Now we go here to 29. 29 is set up the same as 28, except for we have a subtraction sign in between these parentheses. So we would do the same thing we did in 28 with the first parenthesis. We would drop the parenthesis and keep everything the same. But with the second parenthesis, since we have a subtraction sign, we have to change the sign of everything inside this parenthesis. So it'll be negative 4x squared minus 5x plus 7. Now, we combine the like terms. 5x squared minus 4x squared is x squared. 7x minus 5x will give us a positive 2x. And negative 3 plus 7 will give us a positive 4. So that would take care of problem 29. Now, if you look here at problem 30, 30 is basically a combination of problems 28 and 29. So, again, this first parenthesis, we would just drop the parenthesis. So we had 2r squared plus 2r minus 7. The second parenthesis, since we have a minus sign in front of it, we would change the sign of everything inside that parenthesis. So this would become a positive 8r squared plus 2r minus 7. And then the last parenthesis, since it has a plus sign in front of it, we would drop everything in the parentheses. And we would keep all of the signs. So we have plus r squared plus r plus 10. Now we're going to combine the like terms. We had 2r squared, 8r squared, and r squared. So that would give us 11r squared. Next we had 2r, 2r, and r, which would give us 5r. Then we had negative 7 and negative 7, which is negative 14, plus 10, which would give us a minus 4. And that is the final answer for problem 30. Now, we go here to problem 31. Now, since you have copied problem 28 and 29 already, I'm just going to erase those because I have a lack of space here. So now, we're going to go to problem 31. Now, with problem 31, we had negative 3 times the parenthesis 4x squared minus 5x plus 6. We will use the distributive property. So now, with the distributive property, we will have negative 3x times 4x squared, negative 3x times a negative 5x, and negative 3x times 6. So this will give us negative 12x cubed plus 15x squared minus 18x. Now, we're done with this because there are no more like terms. So this takes care of problem 31. Now, problem 32. We have two binomials multiplied by each other. So we know we will multiply them. So we would take negative 2 times 4x, negative 2x times negative 7. Then we would take a positive 3 times 4x and a positive 3 times negative 7. Negative 2x times 4x is a negative 8x squared. Negative 2x times negative 7 is positive 14x. 3 times 4x is 12x. And 3 times negative 7 will give us a negative 21. So now we have negative 8x squared plus 26x minus 21. So that will take care of problem 32. Now we want to deal with problems 33 and 34. So now with problem 33, if you notice, we have a parenthesis squared here. So now with that parenthesis squared, that means we have to write this parenthesis twice. So it'll be 2x plus 5 times 2x plus 5. So now we will multiply that. It'll be 2x times 2x plus 2x times 5 plus 5 times 2x plus 5 times 5. So we're using the distributive property again. So we have 4x squared plus 10x plus 10x plus 25. Now if you notice, we can combine these 10x's. So our final answer would be 4x squared plus 20x plus 25. So now we have to go back up here to do problem 34. Now with problem 34, if you notice here, this is going to be a very short problem because we have a binomial multiplied by a binomial, and we know that they are conjugates of each other. And whenever we multiply conjugates, we can just do this here. We'll multiply the first value by the first value, which will give us 9x squared, and the last value by the last value, which will give us minus 25. And that is our final answer. Now we are going to go down here to problem 35. If you look here at problem 35, you notice we have a binomial times a trinomial. So, with us having a binomial times a trinomial, we know that that binomial times a trinomial. So, we take this binomial times this trinomial. So, we would have to take 3x times 4x squared. And then we would take 3x times 3x. And then we would take 3x times 2. Now, we would take this minus 3 times 4x squared minus 3 times 3x, and then minus 3 times 2. So now 3x times 4x squared will give us 12x cubed. 3x times 3x is 9x squared. 3x times 2 is 6x. Negative 3 times 4x squared is a negative 12x squared. Negative 3 times 3x is a negative 9x. And negative 3 times 2 is negative 6. So now we combine the like terms. We had 12x cubed. 9x squared minus 12x squared will give us a minus 3x squared. 6x minus 9x will be minus 3x. Then we'll bring down our minus 6. So that took care of problem 35. Now we look here at problem 36. We're going to take negative 7x squared and multiply by both of these values. So this is the distributive property. So we have negative 7x squared times 2x, and then negative 7x squared times 3. Negative 7x squared times 2x will give us negative 14x cubed, and negative 7x squared times 3 will give us negative 21x squared. And that's the answer to problem 36. Now, the next thing we will look at is problem 37. If you notice here, we have a trinomial divided by a monomial. Whenever we have a trinomial divided by a monomial, we know we will separate each of these terms. Now, I'm going to write that over here. This will give us 12x cubed all over 3x minus 7x squared all over 3x, and then plus 6x over 3x. 12 divided by 3 is 4. X cubed divided by x is x squared. Then we know this is going to be negative. We know 7/3 is going to remain 7/3. but x squared divided by x is x. And then plus 6x over 3x will leave you 2. So this right here is the final answer for problem 37. Okay, now, if we look here at problem 38, we just have basically a multiplication problem here. We can do cross simplifying. 8 goes into 8 once, 8 goes into 16 twice. And then there's nothing else we can simplify out. So we will multiply this. I'm going to write the answer over up in here. 3 times 2 is 6, and 1 times 5 is 5. That takes care of your fraction. Now we do a squared times a, which is a cubed. So this is the answer to 38. Okay, now, we go down here to 39. It says identify each polynomial as a monomial, binomial, or trinomial. Give the degree of each polynomial. So to determine if it's a monomial, binomial, or trinomial, we look at how many terms we have. We have 1, 2, 3 terms. So that's a trinomial. And remember, terms are only separated by addition or subtraction. Now we look at the highest exponent here. The highest exponent here is 2, so the degree is 2. Now we come here to B. We only have 2 terms here, so that's a binomial. Look at the highest exponent for the variable is 3, so our degree is 3. Now we look here at C. We only have 1 term here, so that's a monomial. Now, since this is 1 term, we add all of the exponents of the variable. So 2 plus 3 is 5, so the degree is 5. Now we come here to problem 40. It says simplify each expression. In parentheses, we have parentheses negative 3 squared, that's 9. Negative 3 squared, that's not in parentheses, we know that will be negative 9. Now for 42, 3 to the negative 2 power, we know that would be 1 over 3 to the second power, which would be 1/9. Now we come to 43. Negative 4 times 7 is negative 28. X to the 5th times x to the 3rd is x to the 8th. 44, y to the 4th divided by y. Same base with division. You subtract the exponents. So it'll be 4 to the 3rd power. Because remember, this y at the denominator is assumed to be taken to the 1st power. Now we look here. We have exponents on the outside. If you look at this exponent on the outside here, wouldn't this just equal 1? Wouldn't this one just equal 1? So we know whatever we get here times 1 will be whatever we got here, right? So this would be 2 to the 3rd power, which is 8. X to the 2nd to the 3rd, we multiply the exponents, and that would give us x to the 6th. And then this is y to the 1st to the 3rd, which would give us y to the 3rd. So our final answer here is 8x to the 6th, y to the 3rd. Now we come here. If you notice, we do have a negative exponent. But let's multiply this out first. 4 times 3 is 12. And then we'll bring our x squared, because there's no other x's here. Y to the negative 2 times y will give us y to the negative 1. Now we know we cannot leave this as y to the negative 1. So it'll be 12x squared all over y to the 1st, or just y. Now, problem 47. We have the same base and we're multiplying. So we carry the base here and add the exponents. So that would be 9 to the negative 3 over 9 to the negative 2. Now if we subtract this, this will give us 9 to the negative 3 minus the negative 2. So this will give us 9 to the negative 1 power, which is 1/9. And then problem 48, 6 divided by 2 is 3. The x's will simplify out. y to the 4th over y to the negative 1 will give us y to the 5th. So your final answer here is 3y to the